Hello, welcome back to BSLIVE. Today we're gonna be doing a bit of study of procedural shader, basically from this artwork that Benny Goffert, or Benny G, I call it. He made this alien pizza procedural shader using cycles in Blender. So we're gonna study this. This is the result, right? It looks beautiful and really mesmerizing. And this is the whole ingredients and the whole procedures. There's a lot of noodles and a lot of lines going in and out of nodes, but we're gonna try to rebuild this from scratch. I'm just gonna follow this. So yeah, so let's just get into it. So let's yeah. So basically, I actually have the previous version of the nodes set up. This is actually before the one before. So this is the other versions, newer one. This is the older versions. It's not simpler, but you can kind of tell the difference in the pattern. And so the easiest to understand is actually to just open Blender and just start to building it from scratch. And the best way to actually sometimes it's good to start from the very end. Sometimes it's good to see the first nodes. And I can make this full screen. We can go back and forth between this and Blender. I hope, oops, this one does not allow me. So anyway, we're just gonna drag it into Blender and look at it. So normally, okay, we're gonna be dealing with cycles procedural shader. We're gonna use cycles engine. I'm gonna divide this into half and divide this into half. I'm gonna turn this into image editor. Just gonna drop this into that layout folder. Okay, now we can use middle mouse button to and zoom in, zoom out of this folder, of this node schema. So we can delete everything here, and we can turn this into a shader editor. We can start with a cube, and so let's save this as Benny G Alien Pizza. So where should we start from here? Where should we start? So let's create material. So by default, we get this principal PSDF and material output. And we're just gonna be creating something that goes into the base color. You can actually replace it with a emission because this is simpler. So it's the final result will be very similar. So I will be using this instead of principles. So I already made a bit of change there. So we can kill this, and you can see the one that's actually doing the job here is the something between texture coordinate and Musgrave texture. So this texture can be anything as well, as long as it can give you 4D texture. So we can create a Musgrave. Before I forgot, maybe we can actually use Voronoi. By default is 3D, we want it to be 4D to add animations on top of it. So this W will give you ability to randomize further the texture using animations. And we need a texture coordinate. By default, this one have everything. With Benny one, it's already been collapsed, only showing the UV. So we need to actually rely on the UV. Yeah, so let's try. If you can actually just plug in the texture, the UV into this, and the result. This is the factor, right? He actually used the map range, which is interesting. It's gonna give you a different result altogether. So let's keep this smaller. Take a look at this render. So we got nothing. Maybe because the setting of the Musgrave is not the same. So yeah, we still see nothing. We know that it's relying on the UV, right? We have the UV of the box. Maybe try the UV on other thing like torus and also like a sphere, because sphere is more like a pizza. So let's do that. Just apply the materials to the same material to those objects. We still don't see anything. And could it be because Benny actually using this map range? So that's possible, or because we have other things like mapping. That could be it as well. So let's try mapping. So this goes into the vector, and this type is points 0, 0, 0, everything is the same. The y is become 0.2. We still don't see anything. Oh, you know what? Because I've been plugging it into the wrong nodes. Let's delete this principal and we just plug this into emissions. Sorry about that. Now we actually started to see something. So Forno and Musgrave giving you a different results. Always a good idea is actually to, while you're scrubbing, you hold the shift and then you play around with the value and see the changes. For now, we're just gonna match it to what's Benny showing here. There's mapping, separate, all right. He separate the X, Y, Z and then combine it back. So that's actually one, this is one holding. And we can replicate that very easily. But I am curious about this map range. So map range, so 0, 1, 0, 0.02 to 1. So that seems to be okay. There's a clamp there. Okay, instead of linear, he's using smooth step. 0, 1, 0, 0.0, 0, 0.02 to 1. You can play around with this value, maybe get more contrast or something. That's probably what it is. So we're gonna continue. Save this. So we're starting to get something, and you can see the UV is giving a different result, and very likely Benny is using the sphere. Okay, and we are looking at this from the top. Right, so Musgrave W is coming from the bottom, random per island. Okay, there is something at the bottom that we're not gonna touch yet, but we can use this separations and combining. Let's see what we're gonna get. Give it a bit of space there. Separate XYZ, combine XYZ. We are basically separating the channel from this vector, because vector is 3 value, and we want to use multiply in X and Y, so we don't care about the Z. Okay, so that's good. It's simpler. And when using math, there's a math, scalar math and a vector math. We're gonna be using scalar math. It's gonna be multiply. Okay, I'm trying to see the pattern. Multiply, combine. Okay, this is gonna go there. And we use another math functions, which is the sine wave, sine trigonometry function. So the value that goes into the sine wave and the output. Okay. So play around with this value and see what you can come out with. You can start to see that it's actually making some kind of flower already. And we're gonna multiply it. We're gonna have this value that's kind of like a pi value. So just duplicate this 3.140, and there's this round and map range, which is for something else from random per island. Right. So we need more space. So something needs to be multiplied by this value, and that's something with round. Okay. We can use a value, and we can use round. Where's round? Okay, round. So it's gonna round the value that we pass in. Gonna multiply it with 3.14. It's gonna go into this value. Right, so there we started to get this flower alien pizza. So this pattern doesn't work too well with box. You can look at it from different angle. It works pretty well on the torus, on the sphere. So let's delete the box for now. So okay, alien pizza and alien donuts. File save as. We're starting to get something, and it's always quite pleasing at this point. We probably already recreated this, and we can continue a little bit more. So don't get too far yet. So we have Musgrave and we have Voronoi. We can try plugging this vector. It's almost like at this point it's almost like a magic on why this is happening. It's a little bit abstract, and it's a little bit, originally it's almost like, kind of like useless if you look at it. Okay, what is this exactly? If you give this to someone, it's too complicated. This one, however, people can enjoy it. It's beautiful, and you can rebuild it from scratch. That's interesting. We have Voronoi that's receiving this magic vector, and we get this interesting looking result. And you can play around with the minimum maximum and get a different pattern. Let's go back to Musgrave for now. You can see how we can control the contrast and get something that's more like black and white. You can have, if you have grayscale, you can actually plug in a color ramp after the fact. I actually like this for now. Okay, so let's go back. Yeah, all right. So yeah, so this smaller number will give you less flowery look. Higher number give you more details, more interesting result. And of course you want to have variations, right? That's why this one, I can see why Benny have random per island. So right, so this is the basic. This is actually a good place to save, and then before you add more randomness. Geometry nodes give you random per island. We only have a single island, only have a single object. If you want to have multiple, then you use array. With array, you have single objects but multiple islands. It's still like single objects but multiple objects inside it. And then you can have array that goes in the y-axis. Right. So he uses random per island and another one actually to control the W for the animations. So the animations, the W will change the pattern as well. Pretty cool. So map range, from the value gonna goes in, and then we're gonna remap it from -1 to 1 to 8 to 32, and the other one is just a multiplier. File save as, multiply by 200. Interesting. So we don't know what's coming in from random per island, but I think it's a value between 0 to 1 or between -1 and 1. Turn off clamp, and this one can goes in there. Can you see it's changing? So we have some variations between 8 and 32. Let's make it smaller. Yeah, I like it between 0 and 1, I think. So we have this. So this we already made a huge difference. We have this all kind of random pattern, and we just need to plug this one, the final one, and this one should be multiply, and this goes into the W to change the animations. Right, so we probably already here. Yeah, I think we rebuilt the whole thing already. So alien pizza and alien donuts. Let's actually make the same thing for the donuts. So we have modifier here, right? Select these objects, Control L, modifier. So we have alien donuts and alien pizza, and they're all just currently black and white. So if I'm not wrong, what Benny did after this is to use color ramp. So use the distance, plug into the color ramp. There's a color, and the color actually randomized as well. That's very clever. Color ramp. So we have some color. So not yet, because currently it's just black and white. Change the hue, something else. Orange and green, or by default this is linear, can be constant, or, and this one also, HSV also have something. Yeah, counterclockwise, of course, give you some kind of spectrum, like rainbow like color. And if we currently the contrast is really high, that's why we don't get much color. So the color is too saturated, of course. If you just use it like this, reduce the saturations, make it darker. Maybe actually use RGB, but use just just use the constant. This way you actually have more control over the result. Yeah, I think that's pretty okay. You were basically at this point just remapping the grayscale value into color, but it shouldn't stop you. Like if you want to go back to the nodes and start to make changes, you can you get a pretty intricate pattern. So I like this actually smaller number. This pattern is easier for my brain. So alien pizza, alien donuts. You can actually bake this out. Currently, we don't have any. I mean, the color is pretty much the same, but what Benny does here, he actually randomizes it with another color and mix both color with the value that's coming from here, from random per island. That's actually a pretty cool idea. Let's do that anyway. We are already pretty far away. Oops. Oh, at this point, my computer is a bit slow. Remix it with random per island. Oh, by the way, if you have this geometry and you have a lot of objects, you can hide it, I think, with a H. Oh, actually, no. Control H. Okay. Control H will collapse everything and only give you the output. Random per island goes into the factor. Random per island is currently only for cycles. Okay, so we have more randomness. Okay, we comes to the end of our live noding or BSLIVE, but anyway, you got the idea. So we start from something that's completely something we cannot understand and totally abstract, doesn't make sense, but we want to achieve this kind of beautiful aesthetic design, right? By going through the whole process, you actually unlock a new skill on your mind. This is why I like nodes. It's a lot simpler than coding. At some point, of course, you want to switch from just visual noding into real coding and coding everything using text. That's a lot harder, but a lot more efficient sometimes. But here, you really can unlock the beauty of procedural nodes using a cycle shader. If you look at it again, maybe it's not as complicated as before, and you understand how to create this, so that's good. And maybe in the future you're just gonna be using parts of it. I think this is how people should learn to code, using nodes and maybe codes later. Use nodes first, like even for things like Python, it's a lot simpler if you can encapsulate into the nodes. Well, anyway, thanks again for tuning in. Hopefully you enjoy this, and I'll see you next time. Thank you. Thanks, by the way, for Benny, for this artwork, and I'm learning something, and this is quite beautiful. Thanks again for sharing this, and I'll see you next time. Bye.